Software engineering spiral model. The spiral model is one of the most important software development life cycle models for risk management. It resembles a spiral with many loops in diagrammatic representation. The spiral's exact number of loops is unknown, and it varies from project to project. A phase of the software development process is defined as each loop of the spiral. Depending on the project risks, the project manager can change the number of phases required to develop the product. The project manager plays an important role in developing a product using the spiral model because the number of phases is dynamically determined by the project manager. The spiral's radius at any point represents the project's expenses, cost, thus far, and the angular dimension represents the current phase's progress. As shown in the diagram above, each phase of the spiral model is divided into 4 quadrants. The following sections go over the functions of these 4 quadrants. 1. Determine the objectives and find alternative solutions. Customers' requirements are gathered, and objectives are identified, elaborated, and analyzed. Then, in this quadrant, alternative solutions for the phase are proposed. 2. Identify and mitigate risks. In the second quadrant, all possible solutions are assessed in order to choose the best one. The risks associated with that solution are then identified, and the risks are mitigated using the best strategy possible. The prototype is built at the end of this quadrant for the best possible solution. 3. Develop the next version of the product. The identified features are developed and tested in the third quadrant. The next version of the software is available at the end of the third quadrant. 4. Evaluate and plan for the next phase. In the fourth quadrant, customers evaluate the software that has been developed thus far. Finally, the planning for the next phase begins. Spiral model risk management. Any adversity that could jeopardize the effective execution of a software project is referred to as a risk. The spiral model's most essential aspect is how it handles unforeseen hazards once the project has begun. The development of a prototype makes such risk resolutions easier. The spiral approach facilitates risk management by allowing for the creation of a prototype at each stage of software development. The prototyping model also supports risk management, but risks must be fully identified before the project's development work begins. However, in real life, project risk may arise after development work has begun. In this case, the prototyping model cannot be used. The product's features are dated and analyzed in each phase of the spiral model, and the risks at that point in time are identified and resolved through prototyping. As a result, this model is far more adaptable than other SDLC models. Why is the spiral model called the meta model? Because it encompasses all other SDLC models, the spiral model is referred to as a meta model. The iterative waterfall model, for example, is represented by a single loop spiral. The spiral model incorporates the classical waterfall model as stepwise approach. The spiral model employs the prototyping model's risk handling technique of building a prototype at the start of each phase. The spiral model can also be seen as supporting the evolutionary model, as the spiral's iterations can be thought of as evolutionary levels upon which the entire system is built. Spiral model benefits. 1. Risk handling. For projects with a large number of unknown risks that arise as development progresses, the spiral model is the best development model to use because it includes risk analysis and risk management at each stage. 2. Large-scale projects. The spiral model is recommended for large and complex projects. 3. Flexibility in requirements. Using this model, change requests in the requirements at a later stage can be accurately incorporated. 4. Customer satisfaction. Customers can see the product's development early in the software development process, and as a result, they become familiar with the system by using it before the final product is completed. Spiral model disadvantages. 1. Complexity. The spiral model is significantly more complicated than other SDLC models. 2. Expensive. Due to its high cost, the spiral model is not appropriate for small projects. 3. Too much reliance on risk analysis. The project's successful completion is heavily reliant on risk analysis. The development of a project using this model will be a failure without a large number of highly experienced experts. 4. Time management difficulties. Time management is difficult because the number of phases is unknown at the start of the project. This makes time estimation difficult.